If you've ever strolled along a beach or peered into a tide pool, you've probably encountered a starfish, also known as a sea star. But why are they shaped like a star? Their characteristic 5-armed star-like shape makes them instantly recognizable. The secret lies in their evolutionary history and the benefits of their unique radial symmetry. Starfish belong to a group of marine animals called echinoderms, which also includes sea urchins and sea cucumbers. All echinoderms share what's called pentaradial symmetry, meaning their bodies can be divided into 5 roughly equal parts around a central axis. Although some sea stars have more than 5 arms, this 5-part structure is typical. Scientists believe that echinoderms evolved from bilaterally symmetrical ancestors hundreds of millions of years ago, but they adopted radial symmetry to better adapt to life on the ocean floor. The star shape offers several advantages for sea stars. For one, it allows them to sense and respond to threats or opportunities from multiple directions. Each arm is equipped with an eye spot, albeit a very simple one, at the tip, enabling the starfish to detect light or shadow. From a centralized mouth on the underside, arms extend outwards so that the animal can reach into crevices or across surfaces to find food such as mollusks or barnacles. If prey scurries to one side, the sea star can pivot or move in that direction without needing to turn an entire front or back end. Another crucial advantage is regeneration. Sea stars are famous for being able to regrow lost arms, and in some cases, an entire body can regrow from a single arm if part of the central disc remains. This star-like, multi-armed structure gives sea stars a better chance of surviving predatory attacks. An arm lost to a crab or fish might slow the sea star down, but it rarely means death. Rather, it's an opportunity to regrow and carry on. Sea stars move using tube feet, tiny water-filled structures on their undersides that function like suction cups. These tube feet radiate out along each arm, working in unison to glide over surfaces. Having multiple arms with rows of tube feet also enhances their ability to cling to rocks or reefs, even in strong currents or waves. Meanwhile, the star shape maximizes contact with the seafloor, which is beneficial for creatures adapted to bottom-dwelling lifestyles. From an evolutionary standpoint, echinoderm ancestors likely experimented with various body plans. Radial symmetry, particularly pentaradial symmetry, proved so effective that sea stars and their relatives still retain it today, long after emerging hundreds of millions of years ago. This shape allowed them to radiate from a central disc, distributing sensory and locomotor organs around their body, and excel in a variety of environments: tide pools, reefs, deep-sea canyons, and more. Sea stars display remarkable diversity within their star-shaped framework. Some have many more than 5 arms. Species like the sun star, Solaster, can boast 10 or more. Others feature spines or bristles for defense. Yet, despite these variations, the fundamental star-like plan endures, evidencing its time-tested success in nature. The star shape isn't merely aesthetic. It underpins how these animals feed, navigate, defend themselves, and even regenerate. Over hundreds of millions of years, natural selection honed this design into the efficient, radially symmetrical body form we recognize today. So the next time you spot a sea star sprawled across the sand, you'll know there's an ancient evolutionary story behind those iconic arms. Ultimately, starfish are shaped like stars because it works. Their pentaradial anatomy grants them environmental awareness in every direction, a robust framework for hunting, and resilience in the face of injury. It's a story of evolutionary innovation that continues to capture our fascination, just as these creatures cling to rocky shores around the world.